We're talking about the sums and differences using sine today to find those extra angles that aren't on the unit circle. We're also going to talk about whenever we have to do trig for any angle using the same sums and differences of sines, and whenever we're trying to verify equations using this. So first thing that we need to see is what are the sum and difference sine formulas. The sum formula, so the sine of a plus b, these are angles, a plus b, is equal to the sine of a times the cosine of b plus the sine of b times the cosine of a. So we're still taking a sine of each angle and a cosine of each angle, but they're in a different order than the cosine sum rules. And the difference formula is just like the sum formula. We have the sine of angles a minus b. This is sine a cosine b minus sine b cosine a. Okay, and now I would take a minute just to note all the differences between the sine sums and differences from the cosine sums and differences. Alright, here in this example we're going to use those formulas to work backwards. Okay? So here we have sine pi over 6 cosine 5 pi over 6 minus sine 5 pi over 6 cosine pi over 6. So I can see I've got sine cosine on each side. The angles swap, and there's a minus sign. So I know that this is a difference formula for sine. So this must be the sine of pi over 6 minus 5 pi over 6. Well, pi over 6 minus 5 pi over 6 is the sine of negative 4 pi over 6. Okay, now since our goal is to keep simplifying, whenever we look at our even and odd or negative identities, the sine of a negative angle is the same thing as negative sine of that angle. And then I can reduce 4 pi over 6 to 2 pi over 3. Okay, so this is the simplified version. Now if I ask you to evaluate that, then I would have to look at the unit circle at 2 pi over 3. The sine of 2 pi over 3 is the y value, so square root of 3 over 2. So since there's a negative out in front, this would be negative square root of 3 over 2. Okay, so now we're going to use the fact that 135 plus 30 equals 165 to find the sine of 165. Okay? So I'm going to use my sine sum formulas. So I know that this would be the sine of 135 times the cosine of 30 plus, we're going to list the sine and cosine in the same order but swap the angles, the sine of 30 times the cosine of 135. Okay, so sine values are the y values at that angle. The cosines are the x values. So if I look at my unit circle here at 135, the sine at 135 is this y value, square root of 2 over 2. And then the cosine at 30 degrees is the x value at 30 degrees. So 30 degrees, the x value is square root of 3 over 2. Plus the sine of 30 degrees, so 30, the sine is the y value, 1/2. So plus 1/2 times the cosine of 135, so here's 135, the cosine is the x value, negative root 2 over 2. Okay, multiply the numerators and the denominators. That's square root of 6 over 4 minus the square root of 2 over 4, because this was a negative over here. Write this as one fraction, square root of 6 minus square root of 2 all over 4. So the sine of 165 degrees is the square root of 6 minus square root of 2 all over 4. Okay, for this example, we're given that the sine of alpha is 3 over 5 and the cosine of beta is negative 12 over 13. We also know that they're both in quadrant 2, which is very important, and we want to find the sine of alpha plus beta. So, my first step is to sketch the two triangles.
It's funny because it looks like a fish and it's called beta.
Bait.
But it's like their friends.
Okay, so these are both in quadrant 2. So here's my alpha.
Yeah. Yes, it does.
Here's beta. Now, I'm told that the sine of alpha is 3 over 5. So, the opposite over the hypotenuse, 3 over 5. And the cosine of beta is negative 12 over 13. Adjacent over hypotenuse. Now, we'll use our Pythagorean triples to figure out what the other side of these triangles is. So, if I have 3 and a 5 on a right triangle, what's this third side? Not just 4, but negative 4. Why is the negative 4 important? Because it's in quadrant 2. Okay, so something 12, 13. What's the height of this triangle? 5, 12, 13. Okay. So now that I've got all the sides, I can find... I'm sorry, I got a phone call and I can't remember where I left off, but I'm pretty sure it was something like that the sine of alpha plus beta is going to be the sine of alpha cosine of beta plus, that's an and sign,
How do you draw beta?
plus the sine of beta cosine of alpha. Alright, so what's the sine of alpha? Well, it was given. These first two things are given. So this is 3 over 5 times the cosine of beta was negative 12 over 13. Plus, now the sine of beta would be the opposite 5 over the hypotenuse over 13. So 5 over 13 times the cosine of alpha, the adjacent over the hypotenuse, negative 4 over 5. Okay, so these things are going to have a common denominator. We have negative 36 over 65 plus negative 20 over 65. So the sine of alpha plus beta is negative 56 over 65. Alright, finally, we're going to prove that the sine of 5 pi over 4 minus x is equal to square root of 2 over 2 times sine x minus cosine x. So this is a sine difference formula. This will be the sine of 5 pi over 4 cosine of x minus the sine of x cosine of 5 pi over 4. Okay. So this is sine of the first angle times cosine of the second angle minus sine of the second angle times cosine of the first angle. Alright, well, I don't know, I can't evaluate for these variables, but I can find the sine of 5 pi over 4. So 5 pi over 4 is right here. The y value is negative square roots of 2 over 2 times the cosine of x. And the sine value is also negative root 2 over 2. So I have minus negative square roots of 2 over 2. Oh, I'm sorry. Blah, 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 blah. It's the same thing, though, because what I meant to say was that the cosine value of 5 pi over 4 is also the same thing. So, again, we have negative square roots of 2 over 2 sine x. Sorry, to anyone watching this. So minus a negative, that's plus a positive. Okay, so now look, I have a positive root 2 over 2 sine x and a negative root 2 over 2 cosine x. Well look, up here I knew I needed a positive sine x and a negative cosine x. If I factor out the square root of 2 over 2, well, I factored out a positive square root of 2 over 2 from that positive sine x, so sine x is still positive. And since I've factored out a positive root 2 over 2 here, this cosine will still be negative. And I proved that these two things were equal.
But how did you factor the square root of 2 over 2?